What is up, Algebra 2? This is lesson 116. How do you work with the fundamental counting principle, permutations, probability, and independent events? And we're going to do all of that in less than 15 minutes, so hold on tight. Here we go. How many different ways can you arrange letters A, B, and C? This option here is if you put the A first, and then you have BC or CB. This is if you put B first, then you have AC or CA. And then if you have C first, then it's AB or BA. So notice you have 1, 2, 3, 4, 5, 6. So there's 6 different ways that you could arrange this. Well, that's pretty easy to do when you just have 3 letters, but what if you had 4 letters, or 10 letters, or 15 letters? We're going to need some way of trying to figure out how to do that without just trying to list out all of our different options. And we call each of these a permutation. Each uses the same letters, but in a different order. We call each arrangement of the members of a set in a different order, in different orders, permutations of the members of the set. So each of these is what we call a permutation. So think about, notice we have 3 numbers. So if we're talking about how many different options we can put in the first position, we would have 3 different letters we could put in the first position. Once we use one of those letters, right? First I have 1, 2, or 3. Once I've used one of those letters, now I have 2 options left for the second position. And then once I've used one letter for the first position and another letter for the second position, that means I only have 1 option left there in that third position. Now if you notice, if you take 3 and multiply it by 2 and multiply it by 1, 3 times 2 is 6. 6 times 1 is just simply 6. And so notice we have 1, 2, 3, 4, 5, 6. So it's kind of a simpler way to get to that same answer that we arrived at earlier, just by multiplying the number of options that you have in each place. So this is what we call the fundamental counting principle. If one choice can be made in A ways and another choice can be made in B ways, the number of possible choices in order is A times B different ways. So simply just multiply them. So this one I always think of pizza because I love pizza and I used to work at a pizza place. So it's like, how many different options can we come up with? And so if someone wanted to order a pizza with just one topping on it, with just one topping, and you offered 4 different options, like thin, hand-tossed, deep dish, or stuffed crust. I don't really know why there's an option. You'd obviously pick stuffed crust. But you have 4 different options here for crust. Then you have 3 different choices for sauce. You can do red sauce, Alfredo sauce, or there's a pesto sauce. So notice we have 3 options here. And then you can pick one of the toppings that they have listed here of black olives, green olives, mushrooms, onions, jalapenos, ground beef, sausage, pepperoni, Canadian bacon, or bell peppers. Obviously you wouldn't pick some of these. But you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice there's 10 options over here. So if you want to find out how many different pizzas could you make with just with a single topping, you'd say 4 times 3 times 10, because I got 4 options, 3 options, 10 options. So this is going to be 120 different single topping pizzas that you could do. Alright, it says a multiple choice quiz has 8 questions and there are 4 possible answers to each question. How many permutations of the answers are possible? So it's just 8 questions on a quiz, multiple choice, there's 4 answers. If you just wanted to randomly generate what the answers would be, how many different options could you get? So the first question, there are 4 different answers. The second question, there are 4 different answers. Third question, there are 4 different answers, etc., 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 etc. 1, 2, 3, 4, 5, 6, 7, etc. So notice since there's 4 options for each of them, this is going to be 4 to the 8th power, which is equal to 65,536. Wow. One of those is going to be the correct answer choice. So if you want to think of probability of that, say 1 divided by that number, you get a pretty small chance of just guessing all of those correct. So So that's kind of the basic idea of the fundamental counting principle. Now let's talk probability. First of all, when we talk about probability, we talk about things that have equal chance of happening. Maybe like a coin flipping, or rolling a dice, or drawing a card from a deck. And each of those events is what we call them. Each of those things that you do is called an event. The sample space is all the different options of outcomes. So maybe if you're rolling a dice, the sample space would be like 1, 2, 3, 4, 5, 6. If you were flipping a coin, it'd just be heads and tails. If you were talking about a deck of cards, it'd be all the different cards that are in a deck. Now when we talk about probabilities, the probability is either guaranteed to happen at 100%, or it's guaranteed not to happen at 0%, or somewhere between those. And a decimal version of that is either guaranteed to happen of 1, or guaranteed not to happen at 0, or some number in between. So normally when we talk about probability, you're talking about a decimal between 0 and 1. Independent events are events that don't affect each other. So like flipping a coin and then flipping the coin again, the outcome of the first does not affect the outcome of the second. However, what we call dependent events are like if you were to draw a card out of a deck and then draw a second card out of the deck, then the first one does affect the second one because now you have less cards and maybe the one you wanted has already been drawn. So those are what we call dependent events. Today we're just talking about independent events, so they don't affect each other. So it would be like if you pulled the card out, looked at it, stuck it back in, shuffled, and then drew the second card out, then those would be independent events. And if you want to find the probability of independent events, then you just multiply them. So if you want to find the probability of getting a heads and then another heads, you just find the probability of the first one times the probability of the second one. Oh, and to calculate, I kind of skipped over this. To calculate the probability of any event, you just say the favorable outcomes divided by the total possible outcomes. So like, if I needed to flip a heads, my only favorable outcome would be heads. So it'd be, there's one favorable outcome, and the total possible outcomes is heads or tails, so it'd be 2. So it'd be 1 over 2. 50%, or 0.5. So just try a couple of this. It says a fair coin is tossed 3 times. Now they say a fair coin, so you're not like Two-Face that has a coin that's weighted that always lands a certain way. A fair coin means that it's equal probability of landing on either side. So they toss a coin 3 times. What is the probability that it comes up heads every time? Now the first time you toss a coin, there is only 1 heads on it, and there are 2 sides. So the probability of getting heads the first time is 1/2. The second time, well, it's exactly the same because there's still just 1 heads and there's 2 sides. And the third time, again, 1 over 2. So if you want to find the probability of getting heads every time, just multiply these 3 numbers together. So 1 times 1 times 1 is equal to 1. 2 times 2 times 2 is 8. So it's 1/8. If you want that as a decimal, divide those and you get 0.125. And if you want that as a percent, you could say 12.5% by multiplying your decimal by 100. So really, any one of those would be a correct way to write that. So not real likely, right? 12% is not real great, but not impossible. It says a fair coin is tossed 4 times and it comes up heads each time. What's the probability that it will come up heads on the next toss? Well, it's kind of a little bit of a trick question because it's talking about coin tosses that have happened in the past. But coin tosses that happen in the past don't affect coin tosses that happen in the future. So it doesn't really matter what happened back here, these 4 tosses that last 4 times. It's just simply asking what is the probability it will come up heads on the next toss. Well, the next time you toss a coin, you still got 1 head side and 2 faces. So then your probability is going to be 1/2, which is equal to 0.5, which is equal to 50%. Pick your poison on which one you like. Alright, your homework's on page 456, 456. You can do the practice set, you can do the 9 through 12, and then 4 more of your choice. Good luck, guys.